Alright, so this is the last video from chapter 3. I thought we would just do a little bit of practice with Lewis dot structures, and follow the rules and do what we do. Alright, so we have, this is chloroform, that first thing, CH3Cl, and it's telling us carbon is central. That means we have carbon, then the three hydrogens are bonded to the carbon, and the chlorine is also bonded to the carbon. So following our first rule, counting the valence electrons, carbon has 4, each hydrogen has 1, so there's 3 hydrogens times 1, and chlorine has 7. So 4 plus 3, 7, plus 7, 14. So we got 14 total. Ugh, that didn't come out well. It looks like a 19. How about 14? 14 total electrons, valence electrons, that we have to put in this. So draw the skeletal structure. So it doesn't matter what side you put the chlorine on. That's not what this isn't. This isn't telling us where it is. It's just telling us what's bonded together. So when I do that, I use 8 electrons. 14 minus 8 is 6. I have 6 electrons I still have to put in this molecule. Remember, the hydrogens only get the one bond and that's it, so they're done. The chlorine, I need to put 6 more electrons around to give it 8 total. When I do that, it gets 8 total, 2 in the bond that's shared with carbon, and then the 6 in the lone pairs. So that's all the electrons I've got. If I look at this, carbon has 8 around it, the 4 pairs as bonds, and then each hydrogen has 2 electrons around it, the shared electrons with carbon, and the chlorine has 8. So that's all set. The carbon and the chlorine are going to have an octet, and then the hydrogens are just going to have the 2. We're good. Okay. PF3. Phosphorus trifluoride. Count the valence electrons. Phosphorus has 5. Each fluorine has 7 because they're halogens. All the halogens have 7. So 3 times 7, because there's 3 fluorines, 21 plus 5 is 26 electrons. So we have 26 electrons we need to put in this. Draw the skeletal structure. The phosphorus with the 3 fluorines bonded to it, just like that. That took 6 electrons. So I've got 20 left. The fluorines are all going to take 8. So we are going to put 3 lone pairs on each fluorine. Whoa, what the hell was that? I think I can erase, can't I? Eraser. Come on. There we go. I'm going to go back to the pen. Oh, that was easier than I thought it was going to be. Okay. Continuing to add dots. Adding pairs of electrons, 3 pairs of electrons around each fluorine. Okay, so now all the fluorines have 8 electrons around them. 6 as those dots, and then 2 in the bond. To do that, to put those 6 around each fluorine, I use 6 on each fluorine, and there's 3 fluorines. 6 times 3 is 18. So I've got 2 electrons left, and those 2 electrons go on the central atom. Anything left over goes on the central atom, like that. And what that does is gives phosphorus 8, so 2, 4, 6 in the bond, and 2 more 8 in the lone pair. So that's the correct structure for phosphorus trifluoride. Each atom follows the octet rule. Each atom has 8 electrons around it. Okay, let's do NO3. NO3 minus. So this is one of the polyatomic ions. That's the nitrate ion. It's not just NO3, it's NO3 minus, so it's an ion. That minus means it's got an extra electron in it, right? It's gained an electron. So when we count the valence electrons, we got to add another one. So nitrogen has 5 valence electrons plus 3 times 6, because there's 6 valence electrons in each oxygen, plus 1. We're adding another electron to make the overall thing negative. So we got 5 plus 18, 23, plus 1 is 24. So we have 24 electrons we need in this. Nitrogen central, N, put 3 oxygens around it. just like that. That used 6 electrons. So we have 6. So we have 18 left to put in there. The oxygens are going to get octets, so we're going to put lone pairs on all those. So 3 sets of lone pairs on each oxygen. Just like that. To do that, there were 3 oxygens. We put 6 on each, so that's 18 electrons we used. So we don't have any left. That's it. Okay? So right now, all of our oxygens have octets, which are good. They've got 8 electrons around them. Nitrogen only has 6, though. Right? Because it's got the 3 bonds, and that's it. And I can't just put 2 dots above the nitrogen, because that would be too many electrons then. That would give a -3 charge, and it's not a -3 charge. So what I'm going to do is take one of the pairs of electrons on one of the oxygens and share it with the nitrogen, making a double bond. So when I do that, I'm going to put the double bond, let's do that right. So, I'm just going to do this right. So, the double bond to the oxygen, and then the lone pairs, there's two lone pairs left, and then each of the other oxygens still has the 3 lone pairs. But now, my nitrogen has 8 electrons around it, right? Because there's 4 bonds around it. That double bond has 4 electrons in it. Each of the single bonds has 2. So the nitrogen now has 8 electrons around it. It follows the octet rule. So this is right now. I'm going to put the brackets around it, remember, because we want to show the charge because it's an ion. We put the brackets around the whole thing and put the charge in the upper right corner. Now, I could have moved a lone pair from any of the oxygens and made a double bond with any of the oxygens. It would have been fine. But we just need to have a double bond with one of them. I chose the left one. You could choose the bottom one or the right one, whatever. One of them has a double bond and the others have single bonds. All right, let's do this last one, carbon dioxide, CO2. Count the valence electrons. 4 for carbon, plus 2 times 6, because each oxygen is 6. 12 plus 4 is 16 electrons. Okay, draw the skeletal structure. Like that. That used 4 electrons. We have 12 left. And then we're going to fill our outer atoms. So we're going to put 6 more electrons in each of the oxygens. And to do that, we use 12 electrons. So there are no more electrons to put in there. Our carbon only has 4 electrons around it, and it wants 8, right? So what I'm going to do is share one pair of electrons. So I'm going to get this thing with a double bond on the left. And you could have put the double bond on the right, that's fine. But I just did it on that one. Okay. And now we've got this carbon, and now it has 6 electrons around it because it's got 3 bonds. But it's not 8. So we need to share another lone pair. We could do it from this left side and make a triple bond over here and a single bond. But in fact, it's better to do it over here. And I'll show you why in a second. And make a double bond with each oxygen. So I get a carbon, the double bond to the left oxygen with 2 lone pairs on it. And then I have a carbon with a double bond to the other oxygen with 2 lone pairs on it. And again, the lone pairs, it doesn't matter what sides they put it on. I put the one on the left and the bottom, and the one on the right on the top and the right. Doesn't matter. They just got to be paired on one side. Okay. If we look at this, we can see the oxygens each have 2 bonds and 2 lone pairs, which is kind of the preferred way oxygen wants to be. And if we had done a triple bond, this oxygen would have had a triple bond and 1 lone pair, and the one on the right would have had 1 bond and 3 lone pairs. That's not the preferred way. So CO2 would look like this. carbon now has 8 electrons around it, so we're good. Okay. One thing I'll note, just as because I noticed it here, the oxygens on the nitrate, 2 of these oxygens have a single bond with 3 lone pairs. Okay, and we'll see that when we have anions, polyatomic anions with oxygens in them. A lot of times you will have oxygens that don't have the double bond and the 2 lone pairs, but will have the single bond and the 3 lone pairs. And if you move on in chemistry, if you take another chemistry course that's a little bit more advanced, we'll explain why that happens. All right, that's basically it for. Oh no, I got one more. Haha, sorry. So one more practice here. So what I want to do with this molecule is glycine. Glycine is the smallest amino acid that's used to make peptides and proteins in your body. Sorry, my throat was getting dry. But that's the basic Lewis structure for glycine, except it doesn't have all the lone pairs it needs. Okay, so what I want you to do is determine the number of valence electrons in glycine. I want you to determine how many electrons are currently in the structure, and then I want you to complete the structure by appropriately adding lone pairs. So, if we look at this and we want to count the valence electrons, what I'm going to do is determine how many carbons, hydrogens, and oxygens there are, and there's a nitrogen too. So we have 2 carbons, 1, 2, 3, 4, 5 hydrogens, 1, 2 oxygens, and a nitrogen. Okay, so let's determine the valence electrons in here. So 2 carbons, and each carbon has 4 valence electrons. 5 hydrogens, and each hydrogen has 1 valence electron. 2 oxygens, and each oxygen has 6 valence electrons, and a nitrogen has 5 valence electrons. Okay, so I've got 8, 2 times 4 is 8, plus 5, plus 12, plus 5. 8 plus 5 is 13, plus 12 is 25, plus 5 is 30. So I need 30 electrons in that structure in the end. Let's count how many there are. And since they're only in bonds, it's pretty easy. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So answering the second question, there are currently 20 electrons in the structure. The first answer was 30 electrons. There's 30 total valence electrons in C2H5O2N. And in the structure we currently have, there's only 20. That means we have to put 10 in there. And they're going to be all lone pairs. So let's look at the atoms and figure out what atoms need some lone pairs. Okay, so the hydrogens are all set, right? Because the hydrogens only get 1 bond and they're done. The nitrogen is going to follow the octet rule. Right now it's got 2, 4, 6 electrons around it. So we're going to give the nitrogen a lone pair to give it 8. The oxygen up on top here has 2 bonds to it. So that means it's going to need 4 more electrons, 2 lone pairs, to give it 8. So now there's 8 electrons around that oxygen. And this oxygen down here also has 2 bonds, except they're single bonds instead of a double bond. So that means it's got 4 electrons around it. So we're going to give it 2 lone pairs to give it a total of 8. So if I count the lone pairs I've added, 1, 2, 3, 4, 5. I had 5 lone pairs, and each lone pair has 2 electrons. So we added 10 electrons, which is exactly what was missing. Okay, so that's just kind of showing you another situation, recognizing that the bonds were all right, but realizing that there were some electrons missing because some of the atoms didn't have 8 electrons around them that needed 8 electrons around them, the nitrogens and the oxygen. If we want to check one other thing, the carbons, this carbon has 4 single bonds around it, which means it has 8 electrons. And this carbon has 2 single bonds and a double bond, which also means there's 8 electrons around that carbon. So the carbons were all set. They didn't need any lone pairs. Right, that is the end of chapter 3. Hopefully, when you do your homework, you'll get this. If you don't, please contact me.